Hello there, this is Alana Tucky, and this is going to be a tutorial for 10.4 number 3 from the study plan. So let's see here. I'm going to click on View an Example. And again, sorry I can't make the text any larger than it is. It says to test H0 that sigma is equal to 25 versus H1, the alternative hypothesis, that sigma is less than 25. A random sample of n equals 31 is obtained from a population that is known to be normally distributed. Nice. Okay, so if the sample standard deviation is determined to be S equals 23.3, compute the test statistic, find the p-value for part B, and will we reject the null hypothesis? Okay, so there's a lot to unpack. First of all, you need to know about what kind of test you're doing. And you're going to be hit with so many different kinds of tests for the final exam that you have to know what you're looking at. So you want to look at your null and alternative, and they very kindly gave you symbols for these. So the sigma is standard deviation. So if you look at your inferential statistics info sheet that of course you will have with you on your final exam because it's just given to you, it's neon green or whatever color it happens to be in your course pack. And we scroll through, those are the formulas at the beginning, and then we have the tests. Now, this is a test for population proportion, a single proportion from chapter 10. That's not what we're doing. And then we have the test for means for mu. Well, that's not what we're doing either. And then we have variance or standard deviation. Ding, ding, that's the one we're doing. Okay, so you have a single standard deviation you're testing. We start talking about double standard deviations or double means and double proportions. That's chapter 11, so we'll worry about that later. All right, so you're working with a single variance standard deviation, tomato, tomato, they're the same difference. So first thing you need to know is that you need to know that it was on a simple random sample, and you need to know that the population is normally distributed. But they gave us that the population was normally distributed, which is good because otherwise we'd be in big trouble. All right, so next we need this compute this test statistic. Now if you look, oopsie, back here, you'll notice that I don't give that little gray section on this one that I do. Let's go back to this one right here, t-test. Well, that's because that's the t-test on the old calculator. So if I press stat, I go to the right to tests, t-test is number 2. So that's a t-test for the mean. But what you're not going to find in here is the chi-square test for a single standard deviation or a single variance because your calculator just doesn't do it. So you're going to have to do this the long way. Now, what's that going to mean? Well, you're going to have to compute your test statistic, which is right here. So chi 0 squared is going to be equal to n minus 1 times s squared over chi, or sigma 0 squared. So hold that thought. Let me get that formula printed up. One sec. There it is. Okay, so we're going to find the test statistic. So we need a bunch of information. We first need to know what n was because n minus 1 is what we need to put in. But if you recall from the problem, n was 31. So it'll be 31 minus 1, which we all know will be 30. Then the next thing I need is the sample variance. S, if you recall, is the sample standard deviation. So when you square it, you really are talking about the variance. That's why it was so important for us to understand what variance was way back in chapter 3. So S was something, let's see, S was 23.3 for part A. So I'll put in 23.3 and I need to square it. And if you like, you can do it like this. Then sigma 0 squared. Okay, well, sigma naught, sigma 0, is the null hypothesis. So in the null hypothesis, you assume a value for your population standard deviation. You don't know what this population standard deviation really is. If you really knew what it was, you wouldn't have to do a test in the first place. But you know what you assumed it to be in that 0 hypothesis. In that null hypothesis, you assumed that it was 25. So you're going to still assume that unless you can prove it otherwise. Right? It's a little bit like Clue. You know, if you ever played that game as a kid, you know, I assume Colonel Mustard did it in the dining room with a candlestick. So you assume 25 is your sigma value unless you can prove it otherwise. Well, even then you wouldn't prove it. You're just going to prove that it's highly likely or unlikely, that kind of thing. All right. So there we go. We have our values. So I just need to do those calculations, and I'm just going to grab a calculator and do that. There's no point in me doing that by hand. Let me see this. Okay, so quit, get out of here. All right, so now if I really want to be crafty, on the new calculators, I can be extra special crafty and hit alpha y equals, and I can do number 1, which is n over d, and it's going to actually make it look like I want it to look like on the screen. I know it's really tiny, but I'll bring the other screen up in a second. So 23.3, close parentheses, squared. You can actually hit the squared little button right here, x squared, and see it makes it a little squared. Then I hit the down arrow to get down to the bottom, and 25 x squared. So let me show you what it looks like. It looks just like what it did on the page. Nice, huh? Really crafty. All right, so 84s can all do this because all 84s can get the new operating system, which is really, really lovely. Now, if you don't have an 84 or you have an 84 that has an old operating system, you can still do this. You just have to type it this way. So you type 31, take away 1, close your parentheses, and honestly, you could just type 30. We all know what that is anyway. Then 23.3 squared. I'm being a little heavy here with the parentheses, but I like it better that way because I want us to be very clear about what's in the numerator and what's the denominator. It's not technically necessary with what we're doing right here, but that's okay. So there you go. Same answer. The one parentheses that is absolutely necessary if you're going to do it is 31 minus 1. But if you just type 30, then you could get the same answers. 30 times 23.3 squared divided by 25 squared. There, that'll work too. Okay, so one way or another we get that the test statistic, is 26.058, oh rats, I already forgot it, 05872. And they probably want it rounded, so I'm assuming they want it rounded to like 2 or 3 decimal places, so 26.06. Let's go back to the, yeah, 26.06, that's what they wanted. All right, so we're done with part A, lovely. So now we need to come up with the p-value. All right, so I'm pretty sure that's what we need. So since this is a left to, oh, okay. So if the researcher decides to test this hypothesis at the alpha equals 0.05 level significance, use technology to find the p-value. Here's a little hint. You don't really need the level of significance to find the p-value. P-value is, it doesn't really care what the level of significance is. Level of significance comes into play in part C when you make your decision, but whatever. Okay, so we can do this a couple ways. I'm going to do it with StatCrunch. I think that'll be best for all involved. Okay, so I'm going to go to Stat, and we are not working off of the normal distribution. So we could use technically, I think, the chi-square here for a calculator, but we could also run a variance right here. One sample variance. We have summary. So you don't have data, you have a summary. They didn't give you raw data for the problem. Okay, so now the sample variance. Oops, we better go find what that is. That's 23.3 squared, right? Because 23.3 was the sample standard deviation, so the sample variance is 542.89. Now you see why we needed you to know that from chapter 4 or chapter 3, 542.89. The sample size was 31. Now what are we testing? Well, be careful here. This is sigma squared. It's talking about variance. It's a pretty standard issue for computer programs to work off of variance, not standard deviation. It's just easier for the computer programs. So what we want is we want to know what 25 squared is, because that was our sigma 0 value. Sigma 0, sigma naught, the sigma from the null hypothesis was 25. So when you square that, you get the null hypothesis variance, which is 625. So you'd say 625, and then we want to say less than, right? Not equal to, because it was a less than, it was a left-tailed test. And say compute. And there you go. There's your p-value right there, right? And notice it came up with the same test statistic we did, which means you could have done it that way all the way along. Crafty, huh? All right, so let me copy all of this. 1 second. There we go. So the p-value is 0.3279. Now, just take a moment and realize what we're doing here. So they actually set up in the problem a test of standard deviation. Sigma equals 25. That's the population standard deviation is equal to 25. We, when we ran it in StatCrunch, because we really have no options for the calculator, ran it with sigma squared, the variance, is equal to 625, because 25 squared is 625. It'll actually get you the same answer, which is why if you look back at your inferential statistics cheat sheet, I say testing hypotheses regarding a population variance or standard deviation, because it doesn't matter which one you're working, right? You just have to be careful, right? If you're working variance, then you square it. If you're working standard deviation, then you leave it, right? The chi-square statistic is built off of variance. Variance is the one that really matters, right? But it's easier for 100 level students to think of it as standard deviation, so be it. But they're basically one and the same. Now, if you look back down here, for the p-value approach, which is what you're trying to do here, it says you're going to have to determine your p-value using a calculator or computer, right? There is no other way to do this, right? So that's the only way you're going to find this. And by the way, there's the graph of what you're doing. So if you were having to do this on a test where you have to show all your steps, this would be your step 4 that you'd have to show. You'd have to draw this picture in the middle right here and then label it. This would be 26. That p-value would be 0.3279, which we just found, and so on. Which leads to step 5, which is part C of our question, would we reject or not? Well, remember, you always reject if your p-value is low. P-value is the probability of you getting what you got. If 25 truly was the standard deviation, what are the chances of getting 23.3? Well, the answer is pretty high, right? So if 25 was truly standard deviation, the true population standard deviation, then getting 23.3 would only be a p-value of 0.3279, which means you got a 33% chance almost of getting that. That's not unusual. That's not rare. That's not special, right? So we would not reject the null hypothesis. Do not reject H0, the null hypothesis, because the p-value is not less than alpha, right? You reject when your p-value is low. That's it, the end. When you have a probability that is low, you're going to reject the null hypothesis because that probability is saying, nah, I don't think this was random chance. I think something fishy was going on. There's nothing fishy going on in this problem with that high of a p-value. Not going to work. All right, so I hope that helps. Let me think. Yeah, for our course, that's really the only way to find a p-value for a test like this, because remember that the calculator, the TI-83 calculator, doesn't really have the chi-square distribution in the same way. It actually does, if you have an 84, have the chi-square distribution. Under distribution menu, it's down there at 7, or it's at 8, right there. But again, it's no purpose at this point to doing it that way. No, never mind. I'll do it. I'll show you. Okay, so you'll grab the chi-square CDF because it's a cumulative distribution function. You want to tell it that its lower is 0 because the chi-square distribution, always the low end is 0, right? Because you squared a distribution, you can never get lower than 0. And you want to get up to your test statistic, which was, oh gosh, 26.05872. 26.05872. And your degrees of freedom is 30. Not your sample size, but your degrees of freedom. And there it is, 0.3279. So if you have a newer 84, you can actually do this if you have this distribution in your distribution menu above the variables button. If you don't, then you're in trouble, right? That's why having the newest TI-84 is better. All right, I hope that helps you guys find the p-value and answer the question. I'll see you back here for more tutorials.